In this question, we've got two paddlers in a kayak, and they can go 1.5 meters per second in still water. If they paddle upstream, so against the current, in an area of the river going 1.2 meters per second, what is their velocity relative to the shore? Well, let's just make a quick little sketch of the river so we can see roughly what's going on. So imagine this is our river, little section of the river. These are the shores, the sides of the river. And imagine the paddler starts at one end and he's got to make his way upshore. So there's your little kayak, kind of a top view, and the paddlers point in this direction. And they're able to go 1.5 meters per second if this was calm water. That's their maximum possible speed if the water was calm. They call that the still water velocity. However, this is not the only velocity in the question. The river itself is pushing back on them. And the water is flowing back against them with a speed of 1.2 meters per second. Now it stands to reason that if you're pushing against the water, you're going to go slower. So really we want to find the combined velocity. What is the total velocity with respect to the shore? So if somebody's standing on the side of this river, having a look at the overall effect, how fast does it look like this boat is going? So the equation is simple. The velocity of the boat in still water combined with or added to the velocity of the river has to give me my overall resultant velocity, which in this case we say the velocity with respect to the shore, with respect to the ground, which is why I use a g. Now because these are vectors, we add them together tip to tail. And whatever gap is left over becomes my answer. That's called the resultant. So let's see how this works. Doesn't really matter what order we do it in. Let's start with our 1.5. I've got 1.5 meters per second. I'm going to commit to a certain length there. Now at the tip of the 1.5, we're going to start our next vector, which is the river velocity, opposing it. So I'll stick to my color coding. The river velocity starts here and goes back in the same direction. Now try and keep some sort of scaling. So 1.5 is clearly a longer vector than the 1.2. Now my final answer always points from where I started this vector diagram, which is right here, there's the start, towards where I finished it down here. So this little gap here becomes my answer. I always put two arrowheads on my answer. So this little pink gap is the velocity with respect to the ground. And we can see from the picture, it's simply going to be 1.5 minus 1.2 meters per second. So we've got 0.3 meters per second. And you can even see the direction. It's still pointed right. It's still pointed upstream. In other words, the kayakers are winning. They're still able to move upstream because their velocity is faster than the river velocity.